Hi guys, welcome to the examples video for lesson 6.2. We're going to do two more examples of using trigonometry to find a missing side. Okay, let's start with this problem on the left. We have a triangle with a 42-degree angle. So that's going to be the angle we use in this problem. We have a missing side W and then a given side 56. Okay, so if we remember back to the notes, the first step is to identify the side that you have and the side that you want in terms of opposite, adjacent, and hypotenuse. So let's do that. Which side do we have? Okay, the side we have is our 56. That's the given. So that's my have side. And which side of the triangle is that? So let's go ahead and just label this whole triangle for 42. So first start with the hypotenuse, that's across from our 90, right? So this side is going to be the hypotenuse. Then the opposite side is straight across the triangle from 42. So this is going to be our opposite side. And that leaves our remaining side, 56, as the adjacent side. All right, so our have is the adjacent side. Now I want to know, what is the side that we want? This is our variable side. So that's this side over here, the W. This is our want side. And we just went ahead and labeled the whole triangle, and we found that that's the opposite side. So my want is the opposite. Okay, so once I know that I have the adjacent, I want the opposite, I need to choose the trig ratio that corresponds to that matches that. So which trig ratio involves adjacent and opposite? Okay, so let's write down SOHCAHTOA, because this helps us remember how the trig ratios are defined. So we can look at this and see sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I'm looking for the one that has adjacent and opposite in it. You can just scan until you see O and A. That's got to be tangent. So we're going to use tangent. We know tangent of an angle is opposite over adjacent. All right, so I'm going to zoom out so we can still see the triangle when we write our equation. Once we've identified our trig ratio, we want to write an equation. So our equation is going to involve tangent, so we're going to start with tangent. Our angle in this case is 42 degrees, so tangent of 42 equals the opposite side, which is W, divided by the adjacent side, which is 56. All right, so we got our equation. I'm going to zoom back in. Now the last step, once we have our equation, is to just solve this guy for W. And before we start on that, let's deal with this kind of obnoxious tangent of 42. Let's turn this into a number. So we're going to turn this into a number, and to do that, we're going to use the calculator. So I have the little image of the calculator again to help us remember. So to do tangent of 42 on a calculator, we're going to punch in the number 42, and then we're going to find the button for tangent, which is, here's all the trig buttons right here, sine, cosine, tangent. We want tangent, so we're then going to hit that button right there. So I'm actually going to do this right now. 42 tangent, I get 0.900404044299784. That's really crazy. Let's round that off. I like to use 2 decimal places, so let's round that to 0.90. Again, to get that number, you need to use your calculator. So I'm going to replace tangent 42 with 0.90 equals W over 56. And then I'm just solving this for W. So I need to get rid of the 56. I'm currently dividing by 56, so let's multiply by 56. Okay. Those guys cancel out. And then on this side, I just need to do 56 times 0.9. So just do that on your calculator. 56 times 0.9 is 50.4. So I get 50.4 equals W. And that's it. We're all good. Okay, let's try one more. Let me bring my calculator over. Okay, so let's follow the same procedure. We want to know our have and our want in terms of opposite, adjacent, and hypotenuse. Okay, so our angle this time is there, it's the 20. The have side is this 30. That's what's given. And the want side is z. That's our variable, right? Okay, so now let's label our triangles so we know which sides those are. Let's start with the hypotenuse. Hypotenuse is across from the right angle, so we see now that our want side is the hypotenuse. So we can fill that in. Okay, then I like to do opposite sides. So start at the 20, go straight across the triangle. So this empty side over there, that's our opposite. Okay, and that means that our remaining side, the have, is our adjacent. So we know our have side is adjacent. Okay, so now we need to choose which trig ratio we want to use. So I'm going to write down SOHCAHTOA again. And I'm looking for the trig ratio that involves both adjacent and hypotenuse. So scanning, sine is opposite and hypotenuse, so not sine. Cosine is adjacent and hypotenuse. I got it. That's what I want. So we're going to use cosine theta is adjacent over hypotenuse to write our equation. Okay, zooming out for a minute to write the equation. Okay, so we picked cosine for our equation, so we're going to use cosine. Cosine of our angle is 20 degrees, equals the adjacent side, which is 30, adjacent 30, divided by our hypotenuse, which is z in this case. Okay, so we've got our equation, now we can just focus on solving that. So this looks a little bit different than the equation we have over here. We have our trig value on the left, but on the right now, instead of our variable being in the top, it's in the bottom, it's in the denominator. And this is going to affect our solving a little bit. But the first thing we want to do is the same as we did over here. Let's turn cosine 20 into a number. So let's use our calculator to turn this into a number. And again, just in case we don't remember, I want to show one more time. To do cosine 20 on our calculator, we're going to punch the number 20 into the calculator. and then find our cosine button and click that button. And whatever number pops up is going to be cosine 20. So I'm going to do that right now. I get another really crazy decimal, 0.9396926, blah, 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 blah. So let's round it off to 2 decimal places. It's 0.939, so I'm going to round the 3 up to 4. So this becomes 0.94 equals 30 over z. Okay, so now here's where it gets a little weird, but stick with me. The z is in the denominator, and I do not want z to be in the denominator. I want to get z out of the denominator. Let's look at what we did over here when we had something in the denominator that we wanted to get out of there. I was dividing by 56, so I multiplied both sides by 56. This time I'm dividing by z. I can do the exact same thing and multiply both sides by z. That seems a little weird, but we're going to see how it works out. So the z's on this side cancel each other. And now I have z times 0.94 equals 30. We'll put this in parentheses. Okay, now I still want to get z by itself, so now I'm working on this side. I want to get rid of 0.94. I'm currently multiplying by 0.94, so to do the opposite of that, let's divide by 0.94. Okay, so now my 0.94s cancel. On the left side, I'm just left with z, and on the right side, I just need to do 30 divided by 0.94. So let's do that. 30 divided by 0.94. I get 31.91489, blah, blah, blah. Let's round to 2 decimal places. That would be 31.91. Oops. Okay, and that's it for the examples. If you need to watch the videos again, you can do that. If you're good, you're good. Please fill out the check for understanding, and then you're done for the day.